All right, so class, today we will be talking about physical and chemical property and changes. So last week we talked about matter, and so atoms and molecules. So now we're going to talk about the properties of that matter. So there are properties used to describe that matter. There's physical. Physical properties, they can be observed without changing the identity. So things like color, texture, density, how it changes from solid to liquid or liquid to gas, its mass, its volume. And then it also has chemical properties. Now, the chemical properties, this describes its ability, the ability of a substance to undergo changes in its identity. So changing from one type of thing to a totally different thing. So then a new substance is then produced. So some parts of aspects of chemical properties, you have reactivity, pH, conductivity, oxidation, which is kind of like how it reacts with oxygen, such as rust. All right, so some examples of properties. So viscosity is a physical, reactivity is a chemical, density is a physical, right? Mass over volume, how much mass it has versus how much space it takes up. Solubility, how well it mixes with the solution, that's physical. And then tarnishing, if you tarnish something, that's going to be chemical because it produces something totally new. So matters changes. So physical change. So the property remains the same. Changes the form of a substance without changing its identity. All changes in state. So freeze, melt, condense, evaporate. You've heard all that with the water cycle, right? It's still water, even though it's frozen, it's ice. It melts into water. It condenses from that water vapor into liquid water again, and evaporates from liquid to gas. So all of that is still water, though. So in other examples below, we have boil, dissolve, break, split, crack, grind, cut, crush, and bend. So think about the verbs, right? Those verbs that are listed below are changing only its state or changing its shape or its texture, but it's still, when you change it and it's still the same thing, that's just a physical change. All right, so a chemical change, this is changes in the identity of a substance. A new substance is produced. So I have one thing, it undergoes a chemical reaction, and then I get a totally different substance. So an example, rust or rotting, burning, decomposing, corroding, oxidizing, which we talked about in the previous slides, like rust, fermenting, and exploding, obviously. If you explode something, you're going to end up with something totally different. So here's some important things. Evidence of a chemical change. By important, I mean, write them down. Change in color or odor, the formation of a gas, the formation of a precipitate, which is a solid. So if I have maybe two liquids and I mix them together and it creates a solid, which is that would be called a precipitate. That's evidence of a chemical change. And then a change in light or heat. Okay, so all of those things are going to be examples or evidence of a chemical change that has taken place. Our favorite time, recap time. So on this recap time, what I want you to do is create a Venn diagram. If you don't know what that is, I inserted a picture below in your notebook, and to compare and contrast physical and chemical changes in matter. So if you go back to previous slides, we talked about what the physical and chemical changes are. And please compare and contrast those. If you don't want to do a Venn diagram, even though I love them, it's totally fine. You can do a T-chart, just chemical on one side, physical on the other, if drawing circles is not your game. All right, so some more examples of matter changing. So a physical change during digestion. So one of the easiest ways for us to try to relate chemical and physical changes is with digestion, because we all love to eat, right? So a physical change during digestion is the mechanical breaking up of food by teeth. Mechanical means it involves movement, right? So if I'm simply chewing on food, right, I'm breaking it up, it's still the same food. So if I pop in, some steak and I'm chewing it up, I'm just putting it into smaller pieces of steak with my teeth, right? So that's going to be a physical change. A chemical change during digestion is the chemical breakdown of food in the mouth, stomach, and small intestine with the aid of things called enzymes. And we'll learn about these later this year. But enzymes are little chemicals that break the food down chemically, because your food starts off as a solid, right? And then your digestive system, your saliva and your stomach acid and some other enzymes, they all mix together and create chyme, which is like a liquid. So actually, after it leaves the stomach and goes through your intestines, it's actually a lovely liquid. So your blood can absorb the nutrients out of it because blood's a liquid. So blood can't absorb the solids, right? It needs to be a liquid. All right. So just a quick recap of some more matter changes. So we have rusting of iron would be a chemical. The dissolving in water would be a physical, right? Solubility. Burning a log would be chemical, right? Melting wax is a physical because I melt it, but I still have it, right? It's still wax. It's just in a different form or shape. And then grinding spices is, again, a physical change because I still have, if I have like cracked pepper, if I make it smaller, it's still, cracked pepper. All right, so now the next slides are going to be like a little game that I want you to do in your, we went a little faster, in your journal. So the first one is a picture of a oxidized or rusted piece of metal. So you have to put down in your journal if it's a physical or chemical change. You don't need to draw the picture, but if you want to just put like what it is and then put a physical or chemical change next to it. Next, on the physical and chemical changes game, we have the Wicked Witch from Wizard of Oz, melting, chemical or physical. We have a picture of an explosion. That is the Earth, and that looks terrible, and I don't want to be a part of that. Oops, sorry. My PowerPoint's a little crazy. So is that a physical or chemical? Delicious little boiling here. So this is a crawfish boil. Is that going to be chemical or physical? Next, I have some delicious, it looks like I'm making a little salsa here. So is that going to be a physical or chemical change with that mortar there crushing up that salsa? Next, we have a devastating forest fire, which if you've caught up with any of the news over the past summer, there's been a lot of forest fires throughout Canada and even in the United States, California, due to the dry conditions. So is that physical or chemical? All right, so here we have a picture of a woman who is fixing a bike tire and she is bending a metal. So is that going to be a physical or chemical change? Here I have a hairstylist who is cutting off some hair. Is that going to be a physical or chemical change? Okay, the next one, I have two liquids being put together, forming a precipitate, which is a solid. Is that going to be a chemical or physical change? The next one, I have at the cutting of a tomato. Is that going to be a physical or chemical change? Oh, here we go. Shredding paper, physical or chemical? Oh, man, my PowerPoint's crazy today. Physical or chemical change. So this is a metal which is going through some tarnishing and possibly even some oxidation, chemical or physical. Here we have the decomposition of what was an animal. So we have the skull left over of that animal. Here we have a sidewalk with cracks in it. Is that going to be physical or chemical? All right, so here we have teeth that are a little rotting. Looks like the gum line is rotted a little bit. Is that going to be physical or chemical? Then our last one, we have Mount Rushmore. So the changes that are happening to Mount Rushmore, is that physical or chemical? Then final recap time. Which of the following changes involved in manufacturing an automobile is a chemical change? Is it A, applying paint to the body of the automobile? B, making plastics from petroleum products? C, making steel from iron, carbon, and other metals? Or D, rolling out steel into sheets? And that'll conclude our video once you answer that question. Thank you.